All right, today in Algebra 2, we're going to look at section 6.4, logarithmic functions. We're going to focus on graphing logarithmic functions with no transformations today. So we'll start out. Number one, we're going to graph y equals log base 2 of x. We're going to identify the domain, the range, the x-intercept, the asymptote, and end behavior. The steps that we're going to take, we're going to write the exponential function. We're going to make a table of values for the exponential function and pick our y values. We're going to plot the points and graph. And then we need to remember that the logarithm is the inverse of the exponential. So we can interchange our xy values, and then we have the graph of the inverse of the log. Remember that inverses of one another are reflected across the line y equals x. So remember that since logarithms and exponentials are inverses of each other, the domain of the exponential will now be the range of the log. The range of the exponential will now be the domain of the log. So everything's just going to be opposite. Right? So we're going to start out writing out y equals log base 2 of x. We want to make the exponential function off that. So remember our circle of life. So we would get 2 to the y equals x. This is going to give us the graph of the logarithm. So x and y, we pick our y values. We're always going to pick -2, -1, 0, 1, and 2. When I plug these in, 2 to the -2 power, so that means I have to flip it, so that's really 1/2 squared, which is 1/4. 2 to the -1 is 1/2, 2 to the 0 is 1, 2 to the first 2, 2 squared, 4. The domain of all of our logarithms. Remember that we cannot have a negative logarithm. We can't take the log of a negative number. So our domain with no transformations will always be 0 to infinity. The range of all of our logarithms will always be all real numbers. The x-intercept of a logarithm with no transformations is always the point 1, 0. The asymptote of a logarithm with no transformations is always the vertical line x equals 0. The end behavior, so we're going to look at as x approaches 0, what does y do? And as x approaches infinity, what does y do? All right, so let's first graph these. I know that my asymptote is the line x equals 0. It's this vertical line. So I'm going to graph that first. So there's our asymptote. So now we're just going to plot these points that we came up with. So 1/4 -2, so over a fourth down -2, over a half down -1, 1, 0, 2, 1, and 4, 2. So this is the graph of y equals log base 2 of x. And this was x equals 0, our asymptote. So now, on this one, we're just going to check the inverse. So remember, the inverse just says change x and y. 2 to the x equals y, that's going to be the inverse. In my xy table, I'm just going to flip these, trade places. Graph this, so over -2 up a fourth, over -1 up a half, 0, 1, over 1 up 2, over 2 up 4. And remember here, exponentials, so this is y equals 2 to the x. Exponentials, that one would have had an asymptote of y equals 0. Then it also reminds us that all inverses are reflected across the line y equals x. So I'm going to go ahead and draw that line. And we can see that if we were to take and flip the one in purple, the logarithm, over that line, it in fact would lay on top of the blue one, the exponential. All right, so now we're just going to graph all of the logarithms without transformations. So the very first one we're going to look at, y equals the natural log of x. The domain, I don't have any transformations, 0 to infinity. The range, -infinity to infinity. The intercept will always be 1, 0. Asymptote, x equals 0. The end behavior, as x approaches 0, what does y do? As x approaches infinity, what does y do? I think we need to go back to that first one we did. I don't think we talked about that end behavior. Sorry. Okay, so on here, the end behavior, as x approaches 0, So as x is approaching 0, my vertical asymptote, notice that my y's are getting smaller, so my y's are approaching negative infinity here. As my x's are approaching positive infinity, as my x's are getting bigger, my y's are also getting bigger, so y is approaching positive infinity. All right, so let's go back to this one. And I want to change this to an exponential. My base of a natural log is e, so I have e to the y equals x. I'm going to make an xy table. Again, we're picking -2, -1, 0, 1, and 2. If I plug in -2, e to the -2, we need a calculator for that, 0.14. E to the -1 is 0.37. E to the 0 is 1. E to the first is 2.72. E squared, 7.34. My asymptote, x equals 0. So now I'm just going to plot these points. Over 0.14 down -2. 0.37 down -1, 1, 0, over 2.72 up 1, over 7.34 up 2. So this is the graph of our logarithm. We can talk about the end behavior as x is approaching 0, y is approaching negative infinity. As x is approaching infinity, y is also approaching infinity. We're going to look at one more of these today. Y equals log base 1/2 of x. Again, I know that my domain, 0 to infinity, because I don't have any transformations. My range, negative infinity to infinity. My x-intercept will be 1, 0. My asymptote, x equals 0. My end behavior, as x is approaching 0, what's y approaching? As x is approaching infinity, what is y approaching? Make our exponential function. So my base 1/2 to the y power equals x. That's going to give us the graph of the logarithm. XY table. Again, we always pick -2, -1, 0, 1, and 2 for our y's. So now when I plug in 1/2 to the -2 power, that means I have to flip my fraction. So it's going to really be 1/2 squared, 2 squared, 4. 1/2 to the -1 becomes 2. 1/2 to the 0 is 1. 1/2 to the first power is 1/2. 1/2 squared, 1/4. And I'm going to graph my asymptote. Now I'm going to plot these points. So over 4 down -2. Over 2 down -1. 1, 0. 1/2, 1. 1/4, 2. So this is my graph this time. So now let's talk about end behavior. So this time, as x's are approaching 0, my y's are actually getting bigger. My y's are approaching infinity. As my x's are getting bigger, as x approaches infinity, my y's are getting smaller, negative infinity. So notice the difference when my base is a fraction, the difference in end behavior, the difference of the way the graph looks, versus when my base is a number, not a fraction, my end behavior and the shape of the graph. And so that's all that we're going to do today. We're going to focus solely on graphing logarithms with no transformations. Our homework will cover only this, and then tomorrow we will look at graphing logarithms with transformations.